This is worksheet 2.1 kinematics, question number 11. I'm going through this question because it's a very long question and some of you tried it. Well done. Okay, but for those who didn't try it or you had difficulty doing this question, let's go through it together. Two trains, P and Q, travel the same parallel tracks between two stations. So P traveled from here, Q started at time 0. Time Q started at T0 and P started when it's 10 minutes. So that's why they have different starting points. Explain how figure 1.1 shows that when moving, train P has a greater speed than train Q. This question is an explanation question. Not only they ask you to explain with reasons why, they ask you to use the graph, using information from the graph. So let's look at the information from the graph. If you observe that both trains traveled 120 kilometers, well done. They traveled the same distance, but train P took a much shorter time. In fact, if you count the amount of time that train P took, is only 10, 20, 30, 40, 50, 60 minutes compared to train Q in 90 minutes. So there's two ways you can write this answer. Number one, you can write train P took 30 minutes lesser than Q. Not just that, but to travel the same distance. So you need to talk about both the distance and the time taken. Then you know that it has a greater speed. However, if you want to use the graph directly to tell you, you can also write this answer. Train P has a higher gradient, higher slope, showing it has a greater speed than Q. So these two answers tell you that it has a greater speed than Q. Now other people use similar answers that they are very good tries. They say that P started later but yet still reached earlier than train Q. That is also a correct answer. The next question, determine the distance traveled by train P at time 70. So let's look at 70. There's a 70 over here. 70, 70, 70, 70, 70. It has reached the end, which we said that answer is 120 kilometers. Some students make a mistake here by taking this to be 125, which is a careless mistake. Count the number of squares correctly. Okay, let's go further. Determine the speed of train Q when it's moving. So when it's moving, it's only the part of the graph that is sloping upwards like this. And give your answers in km per hour. During a question like this, I will highlight the important information so that later when I make any calculation, I must make sure that it's in the same units. So for train Q, speed is equals to distance over time. The distance we have just found, we know that it's 120 km. So 120 km, same units, nothing needs to be done to it. But let's look at how long it took. Train Q started from here, ended here. So 90 minutes. Do I just write 90 minutes here? No, because it is kilometers per hour. So I need to do a separate steps. Change 90 minutes to 1.5 hours. And if you divide accordingly, you should get an answer 80. Finally, another train R leaves on the same journey. It travels at the same speed as P. Now earlier on we said that speed is related to its gradient. So when we say same speed, it means it has the same gradient as P. Same gradient as P. But the thing we know is that it leaves 20 minutes later. So let's draw that onto the graph. I'm going to use a red pen to make it clearer to you. So we know that this is the gradient of train P. If train R has the same gradient, then we can shift the ruler to ensure that it is the same gradient wherever it is, the same slope. And we know that it started 20 minutes later than train P. So train P started here, 10 minutes, 20 minutes. So 20 minutes later, it starts from here, and you draw a parallel. So that's where the 2 marks come from, starting 20 minutes later and same gradient. So this is how train R is drawn.